Hello, grade 10s. We're going to be starting our study of chemistry today in a series of short sprints called learning sprints. And our first of those is going to be a review of what we covered in grade 9. So back in grade 9, you learned what an atom was. And an atom was defined as being the smallest part of an element that still has all the properties of that element. Suppose for a moment that we had a piece of gold, like perhaps a gold ring, or maybe even a stack of gold bars. If I were to take this piece of gold and cut it in half, and then take that half and cut it in half again, cut it in half again, cut it in half again, and on and on and on. The smallest piece of gold that I could get that was still gold would be a gold atom. So what happens if you try to cut something smaller than an atom? Well, you can see from this picture that we have here of an atom, and this would be an atom of beryllium, that beyond the level of an atom, smaller than a level of an atom, we've got tiny little particles called protons, neutrons, and electrons. So those tiny particles, the protons, neutrons, and electrons, are called subatomic. Subatomic means below the level of an atom. They're smaller than an atom. So we need to remember what the three different types of particles are, because they make up all atoms no matter what kind they are. Electrons are super tiny. In fact, they're so small we consider them to not even have any mass at all. In chemistry, we use the symbol E- for an electron because they have a negative charge. In the middle of the atom, we can find protons, which have a positive charge, so we use the symbol P+. These are quite large and heavy particles that are found in the middle of an atom. And we will also find another large heavy particle called a neutron, which we use the symbol N0. Zero meaning no charge. We call that neutral. So all atoms are made up of different amounts of protons, neutrons, and electrons. It doesn't matter what kind of atom we have. So if an atom is this one little particle made up of protons, neutrons, and electrons, what's an element? Well, an element is any substance who, every time we look at an atom in that substance, they're all identical. All of the substances who have the same atomic number. So an element is a substance whose atoms have the same atomic number. Now, the atomic number is the same way of saying the number of protons in the nucleus, and that's important. That's the definition of atomic number. Atomic number means how many protons we have. So the protons is the only thing that defines the atom. We can change electrons in chemistry, it's still the same element. We can change neutrons, it's still the same element. But if you change the protons, you have a completely new element. So the protons and the neutrons are going to be found in the middle of the atom, and the middle of the atom is called the nucleus. Electrons are going to be swimming around the nucleus. We usually draw them in rings, and they're orbiting kind of like the way planets orbit the sun. And they don't account for any of the mass, but they can come and go. We can move electrons around easily as chemists. They're easy to do. And in that nucleus, in the middle, is where we're going to find our protons and our neutrons, and those are the heavy pieces. So the nucleus here, we can see the word nucleus, just talks about this central part. And in that central part, we've got our protons and we've got our neutrons. And that's accounting for all of the weight, the mass of the atom. So if I were to put an atom on a scale and I were to measure how heavy it would be, I was to find its mass, what the scale, and it would be a very special tiny scale, would be measuring was how many protons and neutrons I have. Remember, electrons have no mass. And because they have no mass, all of the weight, all of the mass that scale would show would come from my protons and my neutrons. Now remember, we already said protons was the same as your atomic number. And the atomic number is always given on our periodic tables, and you have one at the front of your book. And that number in the upper part of the square tells you how many protons you are in each of the atoms of that element. Now, one of the things that we said could change was the electrons, and other things that we said that could change was the neutrons. Let's see how that changes elements at all. In the picture that you see in the center of your screen, you'll see 3 different types of hydrogen atoms. These are called isotopes. Oops, that's not very helpful. Isotopes are different forms of the same atom, and what makes them different is the neutrons. In an isotope, there's the same amount of protons, but they're going to have different amounts of neutrons. Let's take a look at these 3 different atoms. In each of these 3 atoms, we are seeing 1 proton. They all have 1 proton. Because they all have 1 proton, they are all hydrogen. It is the only thing that can't change without changing the element we're talking about. We also would notice that they all have only 1 electron floating around in the first ring. The electron's not changing a whole lot. Even if that changed, it would still be hydrogen. But what's different is the number of neutrons. The first version has no neutrons. The second one has 1, and the third one has 2. Remember that the mass depends on the number of heavy things in the middle. So in this first one, the mass of that atom would be 1. In the second atom, because we have 1 proton and 1 neutron, it weighs 2. And in the third one, we have 1 proton and 2 neutrons, which would weigh 3. So these are all hydrogen, because they all have only 1 proton, but the mass will differ because they're going to have different amounts of neutrons. And that's what isotopes are. Isotopes are what we call it when atoms get different numbers of neutrons. Now, atoms can also gain and lose electrons as well. And remember, electrons are negative things. So if electrons are negative things, and I gain electrons, I add more negatives, well then my atom is going to pick up a negative charge because I put a whole bunch more negatives on it. By the same token, if I remove or lose electrons, then the atom is going to become positive charged because it's missing some of its negatives. It'll have more positives in the middle, it'll be missing them. What we want to remember is any time we gain or lose electrons and get a charge, an atom that now has a charge is called an ion. And that's important for us to remember. So we now need to understand the difference between an atom, an isotope, and an ion. In an atom, the protons are equal to the electrons in the rings, and so there's no charge on it. In an ion, we have a different amount of electrons than protons because some have been gained or lost, so might have a positive or negative charge. And in an isotope, we have different forms of atoms. They're still atoms, but the amount of neutrons in the middle might be different from one to the next. So how do I figure out how many protons and neutrons and electrons there are in an atom and draw them? Well, the most common way that we've drawn them before in grade 9 is to do Bohr diagrams. Bohr diagrams were named after Niels Bohr, who first got the idea that electrons are probably orbiting the middle, the nucleus of the atom. So when we go to draw a Bohr diagram, we know we're going to be putting our protons and our neutrons in the middle. We're going to be putting them in the nucleus. So the nucleus is the central part of the atom, and all the protons and neutrons will be there. The electrons will be in the rings surrounding the nucleus. And so let's review, how do I know where to put everything, how many I'm going to need, and how that's going to look. So when I want to go and draw a Bohr model, the first thing I'm going to have to do is determine how many of these different kinds of subatomic particles, how many protons, neutrons, and electrons I'm going to need. And I find that information by looking at my periodic table. So let's consider an element on the periodic table. If you look at the periodic table, that's at the front of your booklet, you could see, for example, they have a nicely labeled diagram there of the hydrogen atom top and center. And this symbol here is the symbol for the atom. It tells us which atom we're talking about, which element we're describing. The number up in the top corner is your atomic number. And it is one of the most important numbers that we have and that we have to know, because the atomic number, this number here, tells us how many protons we have and also how many electrons we have. So for example, in the case of hydrogen, because the atomic number is 1, we will have 1 proton when we draw this, and we will have 1 electron. How do I figure out how many neutrons there's going to be? Well, here you're going to have to do a little bit of math. Take a look at the next number that you have down at the bottom. This number here is the mass of one atom. Now what I want you to do is round it off to the nearest whole number. So 1.008 is going to be equal to about 1. That's how heavy hydrogen atoms are. They're about 1. So if I take the mass, which in this case was 1, and from it I'm going to subtract the atomic number, which was the number of protons, which in this case was 1, then I get an answer that tells us the amount of neutrons. In this case, we can see here there would be 0 neutrons. And that's very possible. We can have any number of protons, neutrons, and electrons. So we'll do more examples of this. I just wanted to show you where everything was coming from on our pictures. So remember that my protons and my neutrons are going to go in the center. They are going to go inside the nucleus. So I'm going to draw a circle for my nucleus, and I'm going to put a P+ for protons and an N0 for neutrons. I'm also going to need to know where to put my electrons, and they're going to be put in rings called shells. And I quite often draw them as dotted rings, but you don't have to. And how do I know how many shells that I have to draw? Well, there is a cute little trick you can do, and you can count the period. The period is the horizontal row that you find that atom in on the periodic table. So you'll notice your periodic table is a big grid. It's got the vertical up-down columns and the horizontal or side-to-side columns. So each element could be found in one of those periods, one of those rows. And hydrogen's in period 1. In fact, period 1 is really small. Only hydrogen and helium are found in it. So it would only need 1 ring. If I'm drawing a different element, it could need 2 or 3. So count which period it's in, and that'll let you know how many shells you're going to need. And then we're going to start filling up this diagram with the right amount of things. To put the electrons on, we have to remember that each ring can only hold so many. That very first ring, that first shell, can only hold 2 electrons. And then it's full. So the first shell holds 2 electrons, and then the next ones can hold 8. In grade 11, we'll start showing you how some of them can hold more. We can hold 18 or even more electrons, but only in special cases. So if you're more interested in that, start taking a look at some of the grade 11 videos that are available. But for now, 288 is the magic pattern that we're going to follow. Let's just do an example together. We're going to do fluorine. So when I take a look at the symbol fluorine, I see the atomic number up at the top here. It's atomic number 9. So because we have atomic number being equal to 9, I'm going to have 9 protons and I'm going to have 9 electrons. I get all of that from my atomic number. I also need to know how many neutrons we're going to have. Remember, to figure out the neutrons, we do some simple math. We know the mass is 19. That's how heavy this is. So it weighs 19, okay? But 9 of those are protons. 19 minus 9, we're going to have 10 neutrons. That makes it heavy enough to weigh 19. So we now know that we're going to have 9 protons, 9 electrons, and 10 neutrons. Protons and neutrons go in your nucleus. We need 9 P pluses and 10 N zeros. Now I'm going to have to add the electrons. To add the electrons, I need to draw rings. So taking a look at fluorine, we find it in the second row, the second period, so I draw 2 rings. Remember that I'm going to need 9 electrons so that it's the same as these 9 protons, that they'll cancel each other. So how do I fill this out? Well, I've got room to put 2 electrons in the first ring. In this picture, we've drawn them as dots, but you can also put E minuses if you prefer. So we have 2 in the first ring. We're still not at 9, but that ring is full. We can't squeeze any more in there according to the laws of physics. So then I go 1 ring next, and I've got room for up to 8, but I'm only going to need to have 7 more. I've got 2 so far, 3, 4, 5, 6, 7, 8, 9. 2 in the first string and 7 in the next string makes a total of 9 electrons altogether. So I've distributed them, I've spread them out around the nucleus. And so this would be a Bohr diagram for what fluorine would look like. Let's take a quick try and see if we can do one for sodium. Finding sodium on our periodic table, we can see its symbol is Na. That's because sodium has its symbol based on its Latin name, natrium. When we take a look at sodium on the periodic table, I can see that its atomic number is 11. This tells me I'm going to have 11 protons and therefore 11 electrons. The positives and the negatives will have to cancel. This number at the bottom is my mass. We're going to round that off to 23. 22.99 is about 23. I know that sodium weighs 23, but 11 of that came from protons. So when we subtract, we can see that 12 of this will be my neutrons. So now I know how many protons, neutrons, and electrons I'm going to have. In the center, in my nucleus, I will put my protons and my neutrons. We have 11 protons, we have 12 neutrons. Now I'm going to draw the rings to put my electrons. When we take a look at sodium, it's in the third period on the periodic table. That tells me I'm going to need 3 rings to be able to have enough space to draw all the electrons required for sodium. I have 11 of them. Always go from the inside out. So electrons start first near the middle, and I know that that first ring has room for 2. So 1, 2 electrons. In the next ring, I have room for 8. So 1, 2, 3, 4, 5, 6, 7, 8. 2 and 8 is 10. I'm still not at 11, so I go one more ring further out and I add one more electron. I like quite often drawing these in shorthand, so you might see me draw them to say 11 positives and 12 negative or neutrals are in the middle. And then in my first ring, we have 2 electrons. In my next ring, you'll see 8 electrons. And in my final ring, you'll see 1 electron. This is another way that we can draw a Bohr structure in a little bit of a shorthand version. So rather than drawing rings and dots, you can see that I have indicated this by starting at my middle, which is my nucleus, and then adding the rings as we move outwards away from the nucleus. So you feel free to use whichever version for a drawing is easier and makes more sense to you. Let's try a couple of sample problems together, and then I'll get you to do some on your own. This is to draw 7 protons in the nucleus of the atom. Well, I know the nucleus is the center, and protons are positive. I'm actually just going to say that there's 7 protons here, 7 positives. There we go. It says to draw 7 neutrons in the nucleus. Well, okay, neutrons also go in the nucleus. That means the middle, 7 neutrons. There we go. It says draw 2 electrons in the first ring. Okay, first ring gets 2. Sometimes we call these rings an energy level, but that's what they mean. Put 5 more in the next ring. Okay, 1, 2, 3, 4, 5 more. Okay. It says, which element is this? Well, of all the things that I put on here, only one thing tells us which element it is, and that's the protons. 7 protons means that we need to go to atomic number 7. And atomic number 7 on a periodic table is nitrogen. So this is the element nitrogen, and symbol for nitrogen is an N. So quick practice. What do these symbols mean on our periodic table? Well, this top number here is my atomic number. And it tells me protons or electrons. The big symbol in the middle is your atomic symbol. It's a shorthand way that chemists have to know which element we're talking about. But just so that we remember, we're also going to have the element's name, and most periodic tables will also give you the name to help you remember, because sometimes the symbol and the name don't look very much alike. And finally, at the bottom, we're going to have the atomic mass, which is how much that element weighs based on its protons plus its neutrons. Can we then figure this information out in a chart form? Well, let's try these together. In this first symbol, the element Li, lithium, has atomic number 3. I know that atomic number tells me how many protons I have, so I will have 3 protons. I also know that it tells me how many electrons I have, so I will have 3 electrons. To find the neutrons, what I'm going to do is I'm going to take my atomic mass and I'm going to subtract from that my atomic number. So my atomic mass was 7 and my atomic number was 3. 7 minus 3 gives me 4. There will be 4 neutrons. Let's try this next one. In this first case, they have given me the atomic mass and the protons. Again, I know that protons is the same as atomic number. So if I have 17 protons, my atomic number is 17. I also know that this column will be the same as electrons. If I've got 17 positives, I must have 17 negatives. How do I find the neutrons? Well, again, atomic mass minus atomic number. E weighs 35, and from that we're going to subtract 17. We will have 18 neutrons in this atom, each atom of chlorine. we're going to get you guys to try some of these as well. So last 2 pages of your booklet, you've got similar type questions to try on your own to see how you're doing with understanding. And that is the first task for Learning Strand 1, Atom Basics.